To get warmed up with your partner, you're going to answer some questions about Baltimore and Cleveland. Pay attention to the format, right? We are using function notation. So I'm not going to give an answer yet, but as we look at this with function notation, this says B of 1930. So we need function B is population in Baltimore. So this is saying the population in Baltimore when? 1930. 1930 goes in. Population is going to come out. So you're going to work through answering 1, 2, and 3 with your partner. Bust that rust off for some function notation. Okay, so checking out these populations. So what does it mean in situation? For one, it means in Baltimore. Year 1930. How many people you guys have? Yeah. There's about 800,000 people. Okay, so if I go to 1930, we're looking right there as our reference point. 1930 in, 800,000 out. For number 2, in year 2000, which is more? So I'm going to go year 2000. I'm going to reference this point and this point. Which one's got more? Baltimore. So it has to be that one. In 1900, which one has more? I'm referencing these points. Baltimore. They're not equal. Okay, when are they equal?
Around like 1942.
So I got right here is one that's equal. And right here too. Yeah, you said that one. So I would say something like B of 1910 equals C of 1910. And we could also say B of 1945 equals C of 1945. Those are describing the two times when they are the same. So, there's our warm-up. Any questions on the warm-up? Bust off some rust with that notation. I like writing this right here. This shows that they're the same. Okay, for those years. And remember, there's just inputs of outputs. What happens if I ask something like B of T equals... let's say 600,000. That means in what year does Baltimore have 600,000? Okay, so then you can say something like, so just remember, you can also be given the output and need to find the input. There's an input and an output. Yeah, right?
I was just wondering, like, if on the test,
yeah.
we just said, like,
for number 3, the years.
Yeah, just like the years.
You'd be all right. I'm just focused on using that function notation. But yeah, if you just said in 1910 and 1945, you'd still be right. Okay. Yep. Thanks for asking. Okay, so we're going to practice this a little more right here. And this data is real data about landlines and cell phones. So raise your hand. Does anybody in here have a landline in their house? Like a phone that plugs into the wall, not for power? Like a phone line plug? Yeah, some people still do. Grandparents probably do. Like my mom still rocks one. We have never had one in my home that I've owned. And so as you can imagine, as cell phones became more prominent, what probably happened to landlines a little bit? They went down. And so these two functions here show people with a landline phone, and the dashed is cell phone only. Which if you're dashed, could you have a landline phone? No, only cell phone. If you're landline, could you have cell phone and landline? Yes, and then you'll notice maybe in a little bit, some of this doesn't exactly perfectly add up to 100. There's probably some people with no phone at all, no cell phone, no landline. All right. Back in the day, you could get by with that a little easier. There used to be pay phones around for some people. You drop a quarter, call somebody. But it's your job with your partner to answer these questions about the landline and cell phone policy. I want you to make sure that you focus on when you get there. Number 4. Number 4 is going to require doing stuff. You're going to need to be able to find the average rate of change.
Like the slope?
It's like the slope, but this is not a line, right? But it is going to be change in y over change in x, okay? So the other ones will go pretty quick. You're going to have to do some stuff on 4 other than just look at the graph, all right? Eyes on the board, mouths closed, please. Okay, looking at problem number 1. In 2006, I kind of like to put little dots down for reference, not a requirement. And what I would write is something like H of 2006 means that in 2006 there were 82% of homes
Let's go.
had landlines. And remember, like, you can't see perfect, right? It's not a table, it's a graph. We got a scale number. So if you're close to 82%, you're on the right track there, okay? And then C of 2006, I'm going to write up here just for space, means that in 2006, about, I put 18%, had cell only. Had cellies only. But you just would have to be close to that, because I could imagine there might be a percentage with no phone at all. Okay, so next up, what is the approximate solution to C of t equals 20? And what that means is, at what year did cell phone only reach 20%? So I'm looking right here at this 20. And it looks like about 2008, right? So I'd say something like C of 2008 equals 20. You could just write like Riley was asking earlier, in 2008. I just like keeping my function notation going. But so C of 2008 means in year 2008, 20% of people had cell phone only. Let's determine if these next two are true. In 2011, are these equal?
No.
No. So nope. And in 2015? Yep. Okay. And then this is the one place we have to actually do some stuff. So we're going to focus on cell only first. And to figure out how it changed from 2004 to 2015, we're going to be looking, I like to draw like some vertical lines here kind of. That just helps me. I'm looking from there to there. So to see how it changed, in 2015 I had about 48% had cell phones. And then in 2004, that was about 6%. So this right here is telling me that it increased by 42%. From here to here is an increase of about 42% total. But it wants an average rate of change, which means I need per year. This is currently over 11 years. So I need to do 2015 minus 2004. And that's just going to divide how much it changed by the 11 years to give me, this is calculator action, about 3.8% increase per year.
What?
Okay.
Wait, how big is the 48 minus 6?
It was at 48 here, started at 6
So you didn't do it all the way to the end of it, you just did it where
to 2015 because 2004 to 2015 is what we're looking at. That's good. So we also need to see landline. And should we expect that to have a positive rate of change or a negative rate of change? Negative is going down. I'm gonna work on that in this space here. Okay, so it ended at 48 instead of started at 48, and it started at 92. So started at 92, ended at 48. And this is good that it's going to give me a negative, right? Because I need my slope to be negative. And I'm going to divide that by the 2015 minus 2004. Those are those 11 years. So again, all this is currently saying is it went down 44% over 11 years. So on average, that's about negative 4% per year. On average, about. And that doesn't. And it also makes sense, like, as this one's going up almost 4%, this one's going down about 4%. Because as there's more cell phones, I'm guessing there's less landline phones. So again, the average rate of change sounds like scary words. It's like a whole statement, but it's just like, how did it change divided by how long it changed by, or whatever your variables are. So change in y over change in x. In this case, gives us our percentage change per year. So be right. Average rate of change will be on the quiz Friday. We do have 2 days to review. That's probably one of the more labor-intensive things. Okay. We've got one more thing to look at. We've got function f and function g. You're just going to answer questions about the functions, okay? So taking a look at input of 2. Which one's more? G of 2. Yeah, it's like almost 8 instead of 4. Okay, f of 4 or g of 4?
They're equal.
And we'll just put equal there, okay? Input of 6,
Add.
the f of 6 is bigger. And then input of 8.
Add. That's what
All right. Is there another value where they're equal?
Yes.
So we already have 4. So you're saying f of 9 equals g of 9?
Yeah.
Let's go check it out. There it is. Okay, and then this next one, there's lots of answers. It can be anything that's here, but not where they touch, and anything that's here, but not where they touch. Okay?
Yep.
Everybody good with that? Because there's like infinite answers technically.
Mr. Mac, what do you think this graph like?
What in context?
Yeah.
Maybe so. If x was time,
Yeah.
we could do time, and we could do maybe height, and maybe this is like a rocket or someone kicked a ball.
Roller coaster.
Okay. Yeah, it went up then down, and then this one's just a zip line.
Yeah.
Roller coaster zip line. But the zip line isn't.
From the zip line.
The zip line hasn't ended yet. It's a longer ride, right? It's gonna keep going till you get
Zip
the
line
ground.
is G.
That's good.
The rocket is up.
Could be. All right, we've got this lesson summary. We're gonna look at it in a minute and a half. So there is your lesson summary with answers. Just remember inputs, outputs. That's all function notation is, and we can use it to say which one's which, right? The comparison is key. There you go. We're gonna make sure we can do all these things.